Hello everyone, today I'll be going over the fill factor problem. We're given a 2-3 tree. For part A, we have to insert 4 numbers that maintain the current height of the 2-3 tree. And for part B, we have to insert 4 numbers that increase the height of the 2-3 tree. Now, for part A, we see that the original tree has a height of 2, so we want to maintain that. The first value I added is 4. 4 is greater than 3, so it's going to get added to the right child here. But since this node is now overstuffed, 5 is going to come up. And since 4 is to the right of 5, which it cannot be because 4 is less than 5, 4 is going to get moved to the middle child of 3 and 5, as seen down here. Now, the height is still 2, which is good. The next number I chose was 1, because I knew that since 1 is less than 3, it can be added to the left child, and this node now has 1 and 2, and the height is still 2, which is great. The next number I added is 24, as we see that 23 is by itself, and since 24 is greater than 19, less than 29, it can be added there and be maintained the height of 2. Last number added is 10, because after the 3 insertions, 7 essentially is by itself, and since 10 is greater than 5 and less than 11, 10 can be added next to 7 and maintaining that height of 2. Now, to explain my approach for part B, I focused on the right subtree as there are numerous overstuffed nodes here, and my overall plan was to overstuff the overall root and these parents so that we can increase the level by 1, increasing the height. The first number I added was 14, and to add 14 is going to get added to the middle of 13 and 17. Since this node is overstuffed, 14 is going to come up here. 14 is up here. This parent is now overstuffed, so 19 is going to have to come up. 19 is over here, and since 14 cannot be to the right of 19, 14 is going to become its own middle child between 11 and 19, as seen over here. And it's going to take 13 and 17 as its children, because 13 and 17 can also not be to the right of 19. The next number I added was 25, so that this can be overstuffed, and it just gets added here. The next number I added was 32, because I knew that if I overstuff this right child, it's going to have to come up and stuff the parent. And since I added 32 between 31 and 37, 32 is going to get brought up here. So 32 is now up here next to 29, and 31 cannot be to the right of 32, so 31 is going to become its own middle child between 29 and 32, as seen down here. Now, I'm exactly where I want, where I have an overstuffed child, its overstuffed parent, and its overstuffed parent. So I know that by adding a value here, it's going to make a value come up here, which overstuffs this, which makes a value come up here, which overstuffs that, which is going to make a value go up by 1 level, which increases the height by 1. The value I arbitrarily chose was 24, because 24 is between 23 and 25. So 24 is going to come up, which is now 24, 29, 32. Since it's overstuffed, 29 is going to have to come up. And so we have 11, 19, and 29. So the overall root is now overstuffed. So this middle value 19 is going to have to come up. And we see that 19 is going to become its own overall root. And since 29 is greater than 19, to become the right child of that new 19 root. And 11 is less than 19, so 11 is become the new left child of that overall root. And we see that the height is now 1, 2, 3. So we increase that overall height by 1 because the overall height originally was 2.